nutrients from below, and as it becomes more stratified, that limits the availability of nutrients. Phytoplankton not only are the base of the ocean food chain, they consume massive quantities of carbon dioxide to produce half the world's atmospheric oxygen supply, equaling the amount of terrestrial production by trees and plants. Their effect on the ocean food chain was recently exemplified by Dr. Tim Parsons, a research scientist at the Institute of Ocean Sciences in Sydney, BC, who hypothesizes that a volcanic eruption might have helped produce BC's largest sockeye salmon run since 1913. The 34 million salmon that returned to British Columbia's Fraser River in 2010 were adolescents in the Gulf of Alaska when the Kasatchi volcano erupted in 2008. Dr. Parsons hypothesizes that the ash from that eruption fertilized the nearby ocean in which the young salmon happened to be swimming with iron, leading to a massive bloom of a type of phytoplankton known as diatoms, which are an unusually rich source of food for growing salmon. The finding that phytoplankton have been dying off for years is evidence that climate change has also been acting detrimentally for years. It is not a futuristic apocalyptic vision. One of our largest sources of food, to say nothing of the very oxygen we breathe, is being adversely impacted and has been for decades. The same thermal stratification of the oceans that is impacting the phytoplankton is both the source of OTEC power as well as the phytoplankton remedy. The most economical and environmentally plausible manner of sequestering atmospheric CO2 is to enhance natural sinks. Natural options avoid the cost associated with industrial separation, capture, compression, and storage of CO2, and reduce potential negative environmental side effects. Weyburn farmers Cameron and Jane Carey attribute a number of consequences on their property, including animal deaths and explosions, to carbon dioxide leaking from a carbon dioxide sequestration experiment being undertaken beneath their property. The most acute example of what can go wrong occurred in the valley below Lake Nyos in northwestern Cameroon on the evening of August 26, 1986. The lake, perched inside a dormant volcano, had become laden with carbon dioxide gas, and when the gas suddenly bubbled out, it asphyxiated nearly every living thing, including 1,700 people in the surrounding community. Natural methods of sequestration avoid such risks and offer reservoirs of large capacity which return atmospheric carbon to its source, the long-term carbon cycle. Enhancing forest growth is an example of a natural method of carbon sequestration which is environmentally benign and with proper management allows for the value-added option of sustainable forest harvesting. Many present-day activities would have to be disrupted, however, to return farmlands to forests or wetlands to increase carbon sequestration, including eliminating crops that currently produce food and biofuels. The consequences of these sorts of actions are already manifest in increased grain prices for crops due to diversion to biofuel production. Deserts, on the other hand, are mostly barren and contribute little to either CO2 uptake or oxygen production, even though they are excellent sources of sunlight, which in combination with water are the elements necessary to drive the photosynthesis process. The missing ingredient for photosynthesis in deserts is water, which open or hybrid OTEC cycles can produce concurrently to the production of electrical energy. This is the third way OTEC limits sea level rise at the same time as it produces a beneficial byproduct.